Hi, welcome to Geometry, Section 3.4, Parallel and Perpendicular Lines. Our objective in this lesson is to relate parallel and perpendicular lines. It's essential that you can use relationships of two lines to a third line to decide whether two lines are parallel or perpendicular to each other. So please take notes here. We have Theorem 3.8. It states if two lines are parallel to the same line, then they are parallel to each other. So draw the picture. If line A is parallel to line B, and line B is parallel to C, then A is parallel to C. It's kind of like transitive property, A to B, then B to C, so then A to C. So it's similar to that concept. Our next theorem is Theorem 3.9. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So, if line M is perpendicular to line T and line N is perpendicular to line T, then that must mean these lines are parallel to each other. And you might remember, this is kind of like corresponding angles also. If these angles are equal to each other because they're both 90, then you could prove using corresponding converse that these lines were parallel also. But this is an easier theorem to use because we can prove it using corresponding converse. And that's what a theorem is, something you can easily prove. So let's prove it. In this plane, line R is perpendicular to line T and line S is perpendicular to line T. We want to prove that these two lines are parallel to each other. So like we just stated, R is parallel to T, S is perpendicular to T, this is given, and that means angle 1 and angle 2 are congruent to each other using the right angle congruence theorem because they would form right angles. And so we could prove that R is parallel to S because they're corresponding angles. And so using corresponding angle converse theorem, we could prove that these two lines are parallel to each other. Here's another theorem, perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other. So this transversal, N, is perpendicular to line L, and L is parallel to line M. Well, if N cuts L at a 90-degree angle, and these are both parallel, then we could easily prove that because the lines are parallel, their corresponding angles are congruent, and therefore N is also perpendicular to M. A theorem is a statement you can easily prove. We could prove this because if we know these lines are parallel, then we know the corresponding angles are congruent. And if N and M intersect at a 90-degree angle, then they are also perpendicular. So continuing on with parallel and perpendicular lines, section 3.7 and 3.8. Our objectives here are to graph and write linear equations, and our second objective is to relate slope of parallel and perpendicular lines. It's essential that you know you can graph a line and write its equation when you know certain facts about the line, such as its slope and a point on the line. You can determine whether two lines are parallel or perpendicular by comparing their slopes. We have slope-intercept form of an equation of a line. That's where y is equal to mx plus b, where m is the slope and b is the y-intercept. We've taught you in Algebra 1, and we reviewed over it in Algebra 2, that b is where you begin when you graph a line. This is where you begin on your y-axis, and m is how you move, your rise over your run. The point-slope form of equation of a line is y minus y1 is equal to m times x minus x1. It's when you have the slope and a coordinate. The coordinate stands as your x1 and y1. And when you plug them in to this equation, y minus y1 is equal to m times x minus x1, then your y coordinate is here, your slope gets plugged in there, and your x coordinate here. So an example of this would be if I have a slope of 2 and a line that passes through 3, 7, then I would say y minus 7 is equal to 2 times x minus 3. That would be the point-slope form of this line. Here's another key concept. Slopes are parallel lines. If two non-vertical lines are parallel, then their slopes are equal. They have same slope. Parallel lines have the same slope. If the slopes of two distinct non-vertical lines are equal, then the lines are parallel. Any two vertical lines or horizontal lines are parallel. So when you have an equation of a line like this, y equals 6 and y equals -2, those would be horizontal lines. They both have a slope of 0, so they are parallel. Or if you have this, x is 7, x is -3, these both represent vertical lines on a graph, so these would be parallel because both of their slopes are undefined. So these both have 0 slope, and these are both undefined. So these two lines here in this coordinate plane, if I wanted to determine whether or not they are parallel lines, I could count the slope, the rise over the run, to see if it's the same, or I could calculate slope using the slope formula, where y2 minus y1 over x2 minus x1 would give me the slope. So for this first line here, line L, I could say that -2 minus 1 over 0 minus -6. So my slope is -3 over 6. So it's -1/2. For my second line, I have 1 minus 3 over 4 minus 0. So I'm going to get -2 over 4, which is -1/2. So I could say that these lines are parallel. Line L1 is parallel to line L2 because they have the same slope. The next key concept that we have is that the slopes of perpendicular lines are opposite reciprocal. So opposite, if one's positive, the other's negative. Reciprocal means when you flip it, right? Reciprocal is to flip. So if two non-vertical lines are perpendicular, then the product of their slope is -1. When you multiply two opposite reciprocal numbers together, so say I have 2 times -1/2. Well, 2 is over 1. Every whole number is over 1. When I multiply this straight across, I'm going to get -2 over 2, so it's -1. So opposite reciprocal means that when you multiply them, the product will be -1. If the slopes of two lines have a product of -1, then the lines are perpendicular, meaning they intersect to form 490-degree angles. Any horizontal and vertical lines are perpendicular. So what that means is that if you have a line that has 0 slope, its opposite reciprocal is an undefined slope. Again, I can use the formula for slope. y2 minus y1 over x2 minus x1 to find the slopes of these lines. So line 1, that's this line here, it would have a slope of -4 minus -2 over 4 minus 0. So -2 over 4, which is -1/2. Line 2, that's this one here, it would have a slope of 1 minus a -5, so I would add, over 4 minus 1. So it's got a slope of 6 over 3, which is 2. 1/2 and 2, when I multiply them together, like we just did a few minutes ago, give us a product of -1, right? 1/2 times 2 over 1 is going to give me -2 over 2, which is -1. Opposite reciprocal. So line 1 is perpendicular to line 2. That's all we have for tonight's notes. Have a great night. See you tomorrow.